Imagine stepping through the doors of a Birmingham workshop in the 1750s, and the first thing that strikes you is the smell. A thick, resinous fog of heated varnish hanging in the air, lit from below by the orange glow of stoving ovens. Inside those ovens, rows of snuff boxes are being baked at ferocious heat, each one receiving coat after coat of lacquer, so brilliant that visitors compared the finish to polished glass. A single box might pass through 12 rounds of varnishing and baking before a painter, sometimes a woman, sometimes a child no older than 10, leaned over it with a fine-haired brush to lay down a landscape, a portrait, or an exotic scene of Chinese pagodas. This was Japanning, and in this part of England, it was turning ordinary sheets of tin and copper into objects that aristocrats across Europe displayed in their parlours. The man responsible for much of this transformation was John Taylor, and his story begins not with lacquer, but with saddles. Born around 1711, Taylor started his working life as a saddler in Birmingham, a town that in those years was little more than a sprawl of small workshops clustered along smoky lanes. But sometime in the 1730s, Taylor abandoned leather for lacquer. A physician named Richard Wilkes noted in his diary in 1737 that the art of Japanning had been brought almost to perfection in Birmingham by one Taylor, who was a saddler by trade. Wilkes described Taylor's japanned snuff boxes as decorated to the utmost degree of nicety, with pieces of history, loving creatures, and landscapes painted to the life. What set Taylor apart was not merely his eye for decoration, but a trade secret, a varnish recipe that no rival could replicate. His formula produced a cheap yet elegant finish, and contemporaries marveled at how Birmingham snuff boxes, when good of their kind, never peeled or cracked, or suffered any damage unless by great violence. The French boxes from Paris, by contrast, were notorious for their japanned coats cracking and flying off in flakes at the slightest knock. Taylor guarded his recipe so jealously that legend held John Baskerville, who would later become one of England's greatest printers, followed Taylor through the streets, trying to discover where he purchased his ingredients. The japanning process itself was an exercise in patience and heat. Workers began with a base, either a thin sheet of metal or, in some workshops, papier-mâché, which was cheaper and lighter. The base was coated with a ground color, typically a deep black made from asphaltum, or lamp black mixed with linseed oil. Then the piece went into a stoving oven, a brick chamber heated to temperatures that would blister bare skin, where the varnish hardened and bonded to the surface. After cooling, another coat was applied, and back into the oven it went. This cycle repeated as many as a dozen times. Each coat added depth and luster, building up that mirror-like surface that made japanned ware so desirable. Once the ground was laid and polished, the decorators went to work. In the larger workshops, teams of painters sat at long benches, under whatever natural light the windows could provide. They worked from pattern books, catalogues of approved designs that ranged from chinoiserie scenes to pastoral English landscapes to classical figures in the Etruscan style. A skilled painter could complete several boxes in a day, but the finest pieces, those destined for wealthy clients, might take a single artist an entire week. After painting, the piece received yet more coats of transparent varnish to seal and protect the decoration, then a final polish with rotten stone or Tripoli powder rubbed in by hand until the surface gleamed. But Taylor did not build his fortune on japanned ware alone. By the 1740s, he had turned his attention to gilt metal buttons, and it was here that he became something truly revolutionary. Not merely a craftsman, but a factory owner in the modern sense of the word. William Hutton, Birmingham's first historian, called Taylor the Shakespeare, or the Newton of his day, and credited him with the gilt button, the japanned and gilt snuff boxes, and the numerous race of enamels. What Taylor did with buttons was to take an article that had been made slowly and expensively by individual craftsmen and break the process into so many tiny steps that each worker performed only one operation, over and over, hundreds of times a day. A visitor named Resta Patching came to Taylor's manufactory in 1755 and left a description that still carries a sense of astonishment. He wrote that Taylor was the most considerable maker of gilt metal buttons and enameled snuff boxes, employing 500 persons in those two branches. He reported that each button passed through 70 different operations performed by 70 different workers, and though he could scarcely believe it, the number seemed to him uncountable. Think about that for a moment. 70 pairs of hands touching a single button before it was ready for sale. One worker cut the blank from a sheet of rolled brass. Another stamped the shape. Another filed the edges. Another drilled the holes. Another applied the gilt. Another polished the face. Another attached the shank. And on through dozens of steps so specialized that each person became extraordinarily fast at their one task. Between 1770 and 1800, 21 patents were granted for improvements in the fastening of clothes, and 19 of them originated in Birmingham. Children as young as 6 or 8 performed many of these jobs, earning anywhere from 10 pence to 8 shillings a week, depending on the complexity of their task. Taylor also controlled his own supply of raw materials. At Thimble Mill, between Bromford and Birmingham, he ran a rolling mill powered by water that turned ingots of copper and brass into uniform sheets for his button factory. A Swedish industrial spy named Reinhold Angerstein visited in 1755 and sketched the machinery, rolling machines operated by 6 men, and a clever device for cleaning and grinding the rolls using a piece of hollowed wood smeared with oil and emery that a workman moved back and forth beneath the rotating cylinder. By controlling both the metal supply and the finished manufacturing, Taylor had achieved something that would not become common practice for another century: vertical integration. By 1759, the Birmingham toy trade, and here toy meant not playthings, but small fashionable articles like buckles, buttons, snuff boxes, and trinkets, employed roughly 20,000 people, with 8,000 of them in the buckle trade alone. Edmund Burke stood in Parliament in 1777 and called Birmingham the great toy shop of Europe. The town was producing 2.5 million buckles a year, most of them for export. But Taylor was not the only giant in this landscape. When he died in 1775, leaving an estate valued at £200,000 and vast land holdings across Warwickshire, the mantle of Birmingham's greatest manufacturer had already begun to pass to another man, Matthew Boulton. Boulton had been watching Taylor carefully. Born in 1728, the son of a buckle and button maker, Boulton had inherited his father's small workshop and immediately began dreaming bigger. In 1760, he described the Birmingham buckle trade to a House of Commons Select Committee, estimating that at least 8,000 people were employed in it, generating £300,000 worth of business annually. But Boulton wanted more than buckles. He wanted to produce the finest manufactured goods in England, and to do it, he needed a factory unlike anything Birmingham had ever seen. In 1762, Boulton began construction of the Soho Manufactory on Handsworth Heath, about 2 miles north of Birmingham's centre. When it was completed in 1766, visitors described it with something approaching awe. The building was designed in the classical style, with a grand facade that looked more like a country house than a workshop. It was powered by a water wheel, fed by a specially constructed mill pool, and at its peak, it employed 1,000 workers. Soho produced high-quality buckles, buttons, boxes, and trinkets in steel, gold, and sterling silver, along with goods of ormolu and Sheffield plate. Sheffield plate was one of Soho's great commercial triumphs. The process had been invented around 1740 by a Sheffield cutler named Thomas Bolsover, who discovered that silver could be fused to copper by heating the two metals together under pressure. The result was a sheet of copper sandwiched between thin layers of silver that could be worked, stamped, and shaped just like solid silver, but at a fraction of the cost. Boulton seized on this technology, using rolling mills to produce sheets of uniform thickness and fly presses to stamp out decorative components with precision. He could manufacture candlesticks, tea urns, sauce boats, and serving dishes that looked virtually identical to sterling silver. The key innovation was die stamping. Rather than casting each candlestick as a solid piece, the traditional London method, which was slow and expensive, Boulton's workers stamped thin sections of Sheffield plate into shaped components using hardened steel dies, then soldered the pieces together. A great variety of models could be achieved simply by interchanging the decorative parts, a different base here, a different capital there, and the price was substantially lower than anything the London silversmiths could offer. For the growing middle class who wanted the appearance of wealth without its full cost, Sheffield plate from Soho was irresistible. But Boulton also catered to those who could afford the real thing. He began manufacturing a solid sterling silver around 1765 and immediately ran into a problem that would change English law. Every piece of silver had to be assayed, tested for purity, and stamped with an official hallmark before it could legally be sold. The nearest assay office to Birmingham was in Chester, 72 miles away. Boulton had to send every candlestick, every teapot, every salver on a jolting cart ride across the Midlands, wait for it to be tested, and then have it carted back. The risk of damage was enormous, the delay was costly, and the whole arrangement was absurd for a town that was rapidly becoming England's centre of metalwork. Boulton launched a campaign. He petitioned Parliament, marshalled support from other Birmingham manufacturers, and in 1773 secured the royal assent for the establishment of an assay office in Birmingham itself. Sheffield received the same privilege at the same time. The Birmingham Assay Office opened its doors that year, and the anchor hallmark it stamped on, approved silver, became one of the most recognized quality marks in the world. With the assay office in place, Boulton's silver production expanded rapidly. But he was already reaching for something even more ambitious: ormolu, the art of gilding bronze with gold, which had until then been an almost exclusively French speciality. The process was as beautiful as it was dangerous. Gold was dissolved in mercury to create an amalgam, which was then brushed onto the surface of a bronze object. The piece was heated in a kiln until the mercury vaporized, leaving behind a thin, brilliant layer of pure gold, bonded to the bronze. The fumes from the vaporizing mercury were lethally poisonous, and the gilders who worked with it suffered terribly. Trembling hands, rotting teeth, and shortened lives were the price of producing those gleaming vases and clock mounts that graced the drawing rooms of the aristocracy. Boulton's ormolu pieces were extraordinary. He produced vases, candelabra, clock cases, and decorative mounts that rivaled anything coming out of Paris. He sold to kings and dukes, and his reputation spread across Europe. But even Boulton acknowledged that ormolu was a difficult business. The French had centuries of tradition behind them, and competing on their home ground required not just technical skill, but relentless attention to design and fashion. Inside the Soho Manufactory, the sheer variety of work happening under one roof was staggering. In one wing, women sat painting enamel boxes, applying transfer-printed designs using the same technique Lady Shelburne had watched at Taylor's factory years earlier. A stamping instrument, pressing an image onto paper, the paper laid on the enamel surface and rubbed with a knife until the design transferred. Metallic color dusted over the moist impression, and the whole thing fired in an oven for a few minutes to fix the color. In another wing, men operated fly presses, slamming steel dies into sheets of silver with a force that echoed through the building like a gunshot. In another, polishers bent over their wheels, buffing candlesticks and tea urns to a mirror finish. In the rolling mills, water-powered machinery flattened ingots into sheets of precisely controlled thickness, a technology that had been in use since about 1740, but that Boulton had refined to new levels of accuracy. The division of labor that Taylor had pioneered with his 70-step buttons was taken even further at Soho. Boulton did not entirely replace traditional craft skills with mechanization. The most delicate chasing and engraving was still done by hand, by highly skilled artisans who commanded good wages. But wherever a machine could do the work faster, cheaper, or more consistently than a human hand, Boulton introduced one. The result was a hybrid system that combined the precision of industrial machinery with the artistry of handcraft, producing goods that were both affordable and beautiful. The toy trade that had built Birmingham's wealth did not stand still, of course. Fashion was a ruthless master. In the 1780s and 90s, shoe buckles, which had been one of Birmingham's most lucrative products, employing 20,000 people and producing millions of pairs a year, began to fall out of favor as laced shoes and simple ribbons replaced them. The buckle makers petitioned the Prince of Wales, begging him to wear buckles and set the fashion, but it was no use. Thousands of workers were thrown out of employment, and the buckle trade collapsed within a generation. But Birmingham adapted, as it always did. The workers who had made buckles turned to buttons, and the button trade expanded to fill the gap. By the early 1800s, Birmingham's hardware factories had become something no visitor could ignore. The town itself was a spectacle of smoke and noise, its skyline punctured by hundreds of chimneys, its streets vibrating with the clang of hammers and the hiss of steam. The Soho Manufactory had been joined by the Soho Foundry, which Boulton and James Watt opened in 1796 as the first purpose-built steam engine factory in the world. But the manufactory continued producing its extraordinary range of metalware: silver, Sheffield plate, ormolu, buttons, buckles, and every conceivable small article that the markets of Europe and America demanded. The next great revolution in Birmingham's luxury trade came in 1841, when George Elkington patented a process that would eventually destroy the Sheffield plate industry and transform silverware forever: electroplating. Elkington discovered that by passing an electric current through a solution containing dissolved silver, he could deposit a thin, perfectly uniform layer of silver onto any metal object submerged in the bath. The result was indistinguishable from solid silver to the naked eye, and the cost was a fraction of even Sheffield plate. Elkington began with a single factory on Newhall Street in Birmingham's jewellery quarter, and by 1880 he employed 1,000 people across 7 factories, producing everything from jewellery to plates and cutlery. Companies as far away as Christofle in Paris and Tiffany in New York adopted his methods. Electroplating was, in a sense, the final act of a story that had begun more than a century earlier with John Taylor's secret varnish recipe. The thread that connected them was Birmingham's relentless drive to make beautiful things cheaper, to take the luxuries of the wealthy and, through ingenuity, machinery, and the organized labor of thousands of ordinary workers, put them within reach of the many. Taylor had done it with japanned snuff boxes that mimicked Asian lacquer. Boulton had done it with Sheffield plate that mimicked sterling silver. Elkington did it with electroplate that mimicked both. Each generation found a way to democratize elegance, to bring the appearance of wealth into homes that could never have afforded the real thing. And yet in every one of these factories, the human cost was written into the walls. The children sorting buttons for pennies a day. The gilders breathing mercury fumes that would kill them before they reached old age. The japanners stoving lacquer in ovens so hot that burns were a daily occurrence. The polishers hunched over their wheels until their backs were permanently curved. Birmingham's factories made the modern world, but they made it with human hands, and those hands bore the marks of the making. Stand today on the site where the Soho Manufactory once rose. There is nothing left above ground, only the foundations buried beneath a modern road. And it is almost impossible to imagine the scale of what happened here. 1,000 workers under one roof, producing objects of astonishing beauty and precision, powered first by water and then by the very steam engines that Boulton and Watt built next door. From a saddler's experiments with lacquer in the 1730s to the electric silver baths of the 1840s, Birmingham's hardware factories traced an arc of invention that changed not just how things were made, but what ordinary people could aspire to own. The great toy shop of Europe had become something far greater, a forge of modern industry, where the future was being hammered, stamped, lacquered, gilded, and polished into existence, one small beautiful object at a time.